crystals which are water soluble, which of course gives you a lot of problems. They melt at rather low temperature. So industrially, they're a little difficult to use, but they use them in telephone systems and phonograph pickups and all kinds of things like that. There were a number of materials that they investigated, including quartz, which we see a lot of today. But what these brothers came up with was a way to grow these crystals, and they were generating crystals of like 500 grams, great big things like this. And I found some of the documents they wrote describing their method of growing it and their recommendations for processing after it's grown. If you want to, this is one of them, you can pass that around. I've got about 4 of those. That one's just raw, right out of the tank. They recommend, after you grow it, to make this, it's tartaric acid, which is cream of tartar cooking ingredient, and sodium carbonate, which you can prepare from sodium bicarbonate just by heating it to about 350, 400 degrees in the oven. There's some videos about how to do this. Basically, you put the cream of tartar in water, and then you just keep adding sodium carbonate until it stops foaming. And then you let that cool, and it'll form little seed crystals. Pull one of those out, heat your solution back up, and then use the seed crystal to grow it just like any other crystal growing project. It'll grow in a couple of different orientations, which I have pictures of here. If you're interested in, they have, typically what I've got here, I grew all mine sideways, which is what the Pierre brothers recommended.
So you're
But
striated
they'll also,
lengthwise.
Yep, that's it. And it'll also grow vertically, which is what's pictured here. But it's not as sensitive in that orientation as it is in the sideways syntax. And then after it's grown, they recommend soaking it in alcohol and then drying it at about 105 degrees. So I did that with this one. I haven't tried it out yet to see if it's any more sensitive than these. But most likely, you don't really need to do any of that stuff because we have access to much more sensitive electronics than they did in 1880, or electronics at all, for that matter. What they were using it for, their earliest applications, was as pickups for telephone equipment, mostly, where they could use the crystal to convert vibrations, like voice vibrations, to a charge that could be used to drive distant receivers. So they had really big crystals that were prepared to be very sensitive so that they could get a lot of charge on the line. Since I'm using an amplifier, I don't really need to go that big. In fact, these are probably really enormous for what I'm doing, but it makes them easy to deal with. I've also got a number of other crystals and ceramics here. One of them is a standard piezoelectric disc that is probably either quartz or barium titanate. I don't know for sure. It's one of these little things that you see in watches and everything's a little brass disc. I have the striker from a lighter, which is lead, zircon sulfate, or some PTZ, which is a material that was developed in about the late 60s, if I recall correctly, that's much more sensitive to shock than the natural crystals, but it's also more expensive. And there's these, typically these little disc capacitors that you find in electronics are barium titanate, which is a very good dielectric. Dielectric effect is related to piezoelectric effect, actually. So the fact that it has a very high dielectric constant also relates to its high piezoelectric constant. And what's interesting about these little capacitors is that in addition to having the capacitance, it's a plate with the ceramic on between it, which makes it a piezoelectric element also. So we will hook that up in a little bit, and you'll see that these these capacitors in a circuit actually can act as a piezoelectric pickup, which occasionally has caused problems for electric designers where the electric signal that they're sending through it will actually cause the capacitor to act, to flex and act like a speaker. That's not so much a problem when they're mounted as these are on little legs, but more modern ones are surface mount. It's a little rectangular block that gets soldered onto the board at both ends, so it's strongly fixed to the PCB. And when you run an electric field through it, if that happens to hit audio frequencies, which coincidentally is where variant titanate happens to be very active piezoelectrically, it can turn the whole board into a speaker output. And if you have multiple of these capacitors on there, you get feedback from one mechanical feedback from one capacitor to the other. So separate circuits can actually be coupled mechanically through this effect.
It's kind of cool, actually.
Yeah, so you can end up with like reverb
and
effects.
then you break the board apart.
Yeah, and if you've got several of them, you can end up flexing the whole board. There's one story that's on Wikipedia, I think, about how typically you use a little capacitor in the sleep circuit of a microcontroller, and sometimes these microcontrollers, when they're sleeping, will check this sleep circuit about 1,000 times a second. So you're hitting this capacitor at an audio frequency, and so when the microcontroller goes to sleep, you get a whine. So in addition to the commercial one here, I have mounted two of my Rochelle salt crystals. One is in a little brass clamp here. One of the other mechanisms for increasing the piezoelectric activity of these is to pre-stress them mechanically, where the large crystals that they're working with would be clamped with about 15 kilograms of force, which would increase the signal that they would get out of it. I don't have anywhere near that with a rubber band. I don't know that that's actually necessary, but it illustrates the setup anyway. And then I've got a second one here that I have. Initially, I attempted to hot glue to these. It doesn't work so well because the crystal melts when you get it hot. So instead, I found that CA glue works really, really well. So what I've done is I have connected a wire on the bottom, heavy copper wire, and then on the top, I have a fine piece of music wire. And so, as if it were like a phonograph pickup, where moving the wire will torque the crystal. And with Rochelle salt, torquing the crystal is more effective than compression for generating voltage. And then I've also got connected to the circuit here, the striker. And I'm using all of these as an input to just a little high impedance audio amplifier, just based on I forget what it is, something similar to an LM386, which is just a single chip amplifier. But it's a very high impedance so that the charge that's generated on the crystal won't bleed away. So what you can do is first I'm going to show you this commercial disc element, which is very sensitive because it's mounted on a large disc, so it picks up the elements very quickly. I turn it on and you can hear that it's picking up any vibrations in the board in the table. Now this is extremely sensitive.
And what kind was that, or?
This is, I'm not entirely sure. It's either.
What'd you steal out of then?
Most likely it's quartz,
Okay.
but I couldn't tell you for sure. They're very common though. If you touch it, it's. So that's the. Now I'll take that off there so you can see that it's just extremely common. I just pulled it out of some equipment, random equipment here. And then this is a striker out of a lighter, and it's also very sensitive. That's a radio signal. So just tapping on it. these will generate, if you click it, of course, it's going to generate 20,000 volts, so I'm not going to do that.
I was
Yeah.
gonna say, that might blow your speaker.
I have a couple little diodes on the input of my amplifier back to back here to clamp the input voltage, but they're not up to that. So it just, any kind of a hard tap on this, this stuff is so sensitive that that'll generate a signal up to about 4 or 5 volts, just tapping it like that. So that's a good one for generating a signal if you need something that's a very strong signal, whereas this one, the little disc doesn't generate nearly as strong as the signal, but it's much more sensitive at picking up vibrations. These are good for if you want to do a ground vibration sensor like a train or earthquake sensor or something like that, or if you want to like put it on the on some stairs to detect somebody walking by or anything like that. And then I'm going to connect up the ceramic disc capacitor. There's a number of different dielectrics that are used in these, and some of them are piezoelectric, some of them are not. It's generally related to how strongly, how high the dielectric constant is. So I think I'm going to hit it with. So not anywhere near as strong as those others, but you can hear that it does do it. And I can't leave it in the circuit because it's also a capacitor and it kills my signal. Okay, so that leaves the two Rochelle salt crystals that I made. The first one is in brass, and again, sounds like a radio because it is. So if I just tap on the housing, you can see that it's converting the impact from that into a voltage. I've just got, the way it's set up is, I've got the crystal clamped, and then I've got a piece of copper wire wrapped around that, and then connected to the input to this
Now, what is
to the
the
circuit.
fade?
What's that?
What is the sound fade?
This.
Oh, okay.
It's picking up the it's very high impedance, so it's picking up, and it's got some diodes on the input, so it's
Getting
taking
your field.
any AM interference and down converting it to an audio.
Probably from the lights.
Yeah. The other day, if the signal is strong enough, if you touch this, you'll get AM 1110. There's too many computers around here. It's probably picked up that.
You want me to get the lights into the house?
Yeah. Oh.
Yeah. There.
It's still,
There's lights on the back?
they're still really high.
Yeah. So definitely, it's picking up the lights there. But so that's and then if I hit it from the side, you can hear that it's not anywhere near as sensitive. So it's the torque that's really generating a signal. Now this other one, if I just brush the little wire here, it makes, so it's twisting the crystal, and you can hear that it makes a very, very
Is that your
strong.
fingerprint?
Yeah. So any kind of a, like if you have something that's rough, like paper or whatever, very sensitive. And while I can't demonstrate it with this signal, just doing a displacement on there actually generates a very low frequency change, so that if you have a microcontroller or whatever on it and you use a charge amplifier, when you just bend the crystal, you can detect a DC signal out of it. So it can be used for various low frequency signals. So that's about it. Welcome. Oh, the one other thing I was going to demonstrate or show you was
Oh, I thought it was safe to fix my hearing aid.
there's these type of crystals that we use for microcontrollers and various other things, televisions. I think this is a color burst crystal from a TV. These are ceramic, not ceramic, they are quartz crystals. And if you take one of these apart, you can see inside that it's a very, very tiny little slice of quartz crystal between two plates that most people have never taken these little things apart. If you want to take a look at it. I haven't actually hooked that one up to see if it's any good as a signal source, but
So what's this part for?
that part is basically it generates a clock signal. You hook it up in a circuit, and that particular one generates a
60 hertz.
3.579545 megahertz signal. And they are very, very precise, although the temperature will cause them to drift.
Yeah, what temperature is that?
Probably at 25 C or something. I don't know. Any questions?
Round disc.
Mm-hmm.
Microphone? Is it, could it,
It will.
you said it would pick up vibrations.
Piezoelectric
on-
effect works both ways, as does the pyroelectric effect. I didn't talk much about the pyroelectric effect, but I think it's all pyroelectrics are also piezoelectric because of symmetry relationships in the crystal, but not all piezoelectric are pyroelectric. Now, there's also, before I forget about it, there's also ferroelectric, which is interesting because the crystals, if you apply an external electric field, will get a spontaneous charge on it, where it'll be one way or the other, not neutral. Whereas a non-pyroelectric, ferroelectric material will have no charge. And that's interesting because you can do, it has a hysteresis loop that will exist whether the external field is there or not. So if you apply the field one way, you can set the charge to one direction, turn off the external field, and it stays in that direction. If you turn it back on, you can reverse it. And so you can use it as a memory device. And in fact, there is a class of memory used for things like RFID cards that is based on the ferroelectric. But most of those relationships are reversible. So if you, with a piezoelectric, if you apply a force, you'll get a voltage, and if you apply voltage, you get a force. The voltage is actually used in piezoelectric motors and various very high precision motion control devices. One of them I looked up as a commercial product is a little, like a little linear motor. It's a box with piezoelectrics in it and a big shaft, a half-inch shaft about that long. And it'll position that shaft within, with steps of 3 micrometers. And it'll do it at up to 50 millimeters per second, minute, something like that. Relatively fast for moving that finely. But it's interesting how they set that up. They have a number of piezoelectric elements where when they apply the force, the electric force, the crystal bends sideways so they can cause these to stretch out and contact the rod and then apply a force to bend it this way. So they move it very, very small amounts. And they have a whole bunch of these, so they work kind of like caterpillar feet. And they move the rod along one direction or the other. And they can do that, of course, at very, very high frequencies. One of the other features of piezoelectrics is that they'll work up to megahertz frequencies, obviously, since that's what we use it for. But they're very commonly used in ultrasonics, like the ping sensor is piezoelectric, probably quartz in that case.
Really?
Yep. And so they are both used to generate the sound and also to receive it. The first application of that was about World War II, I think, when some French dude whose name I forget because it's French invented sonar based on quartz crystals. That was one of the very first applications of the piezoelectric effect in industry. Of course, the success of that spurred a lot of research that went on through World War II. and indeed up until today with these much more sensitive things that you find in the stripers. I think that probably answers the question. And some others, I hope.
Have you played with feeding any of the crystals a DC signal and just trying to get noticeable movement out of it?
I haven't. I didn't have anything really sensitive enough to measure at those scales. The larger Rochelle salt crystals probably are at a large enough scale that you can measure it. I haven't tried yet. That might be an interesting project for some laser interferometry.
It's been a while, but I think I've seen a demonstration of something where the movement was significant enough that you could see it with a simple magnifying glass.
Interesting. Should try that.
But I don't remember what the setup was.
I know that these Rochelle salt crystals can be used as audio output. On the larger crystals that they were describing, 1 to 500 grams, they recommended about 500 or 600 volts as an input signal. These probably would stand up to that as well.
The disc you've got there, I think those are used a lot, yeah, that one,
Yep.
as speakers in the little annoying alarm clocks that just beep.
Yep.
But you're not going to be
This
able to
one-
see that displacement.
Yeah, this one I unfortunately rolled over, so it's not going to be much of an audio source. It fell off the desk and I rolled over it with my chair. So they are actually very tough also. But what's kind of interesting about these, as I understand it, the crystal is actually sideways on there, so that when you apply the voltage, it's expanding linearly across this way to cause the disc to flex. So it's
Sounds
probably...
like the element in an ultrasonic humidifier.
Yes, that's another application is ultrasonic humidifiers. They have a disc that's about that big around in there that is designed, I believe it's actually designed to have a